So this is the picture of the type 2 class A1 biosafety cabinet. It is the front view, this is the side view, and this is the room air and potentially contaminated air and HEPA filtered air. So it quite different from the class 1 biosafety cabinet. The working mechanism of class 2, it differs according to its type, which I had discussed in detail, and this is a brief description. It has an open front with inward airflow for the personal protection, downward HEPA filtered laminar airflow over the work surface for the product protection, and HEPA filtered exhaust air for environmental protection. The room air and the recirculated air are HEPA filtered before flowing downwards over the work area. Class 2 biosafety cabinets can be exhausted into the containment zone or directly to the outside atmosphere through a thimble or hard ducted connection, and it depends on the types. The amount of air that recirculates or exhausts depend on the types. The class 3. Next is about class 3 cabinets. Class 1, class 2, class 3. This class 3 cabinets generally only installed in maximum containment laboratories, and it is specifically designed for the work with biosafety level 4 pathological agents, providing maximum protection. The enclosure, it is a gas tight, and all the materials enter and leave through a dunk tank or double door autoclave. The gloves which are attached to the front prevent the direct contact with the hazardous materials. Class 2 cabinets are sometimes called glove boxes. These custom built cabinets often attached into a line, and the lab equipments installed inside is usually custom built as well. This is the picture of class 2. Class 3, not class 2, class 3. Next, briefly describing the working mechanism. This type of cabinets, it is totally enclosed and it is tested under the pressure to ensure that no particles can leak from it into the room. And also, its supply air is HEPA filtered and exhaust air is discharged to the atmosphere through the HEPA filter. And the operator accesses the work surface by means of heavy duty rubber gloves, which form the part of the cabinet. Several glove boxes can be joined together to extend the work surface. The airflow, it is maintained by a dedicated exhaust system exterior to the cabinet, which keeps the cabinet interior under negative pressure. So the interior of the cabinet is under negative pressure. The class 3 biological safety cabinets should have an attached pass-through box that is sterilizable and is equipped with HEPA filtered exhaust. The class 3 cabinet also can be connected to the double door autoclave used to decontaminate all the materials entering or exiting the cabinet. Next is about the features of biological safety cabinets. So class 1, the phase velocity, airflow, exhaust system are given. Here class 1 have hard duct exhaust system. Class 2 have exhaust to room or thimble connection. Class 2 A2 have exhaust room or thimble connection. Class 2 B1 have hard duct. Class 2 B2 as well as class 3 have hard duct connection. Next is mentioning about ultraviolet lamps in the biosafety cabinets. The CDC does not recommend the installation of UV lamps in biological safety cabinets. The American Biological Safety Association support this position. citing the safety risk to the personnel, shallow penetration, reduced effectiveness in high relative humidity, and frequent need to clean and replace the bulb. UV lamps should not be used as a primary source of contamination, primary source of surface decontamination with the BSC. However, these assertions have been formally disputed in at least one peer-reviewed article which point out that. So, according to this, there is no cited basis for the need to remove the dust and dirt from the bulbs. Properly functioning biosafety cabinets have a very clean air, so dust is less likely to build up. Laboratories are generally air conditioned, which eliminates the concern over humidity inhibition of UV effectiveness. With proper use, UV exposure risk to the users is very low. UV disinfection is effective for germicide and virusicide, as well as it inhibits the DNA contamination from PCR. UV disinfection has the advantage of not leaving the residues like physical disinfectants. The relative safety and risk of UV versus other disinfection techniques should be considered. Next is about maintenance and service. The biological safety cabinets are generally required to comply with that country or region standards. These requirements may be governed by institutional bodies such as TGA, FDA, WHO. Those standards reference several other standards such as, so this standards refers other standards such as AS2243, AS22433 classifies the level of risk that microorganisms pose based on hazard based on their pathogenicity, mode of transmission and host range, along with the current preventive measures and effective treatments. There are specific field test requirements for Class 2 BSCs. United States base for the field testing is NSF 49, and the field test requirement may include air velocity within the work zone, air barrier testing, air barrier testing, that is the barrier between the operator and the product, filter integrity, particle counting with the work zone, gas tightness, this should be checked and maintained, leak testing of the work zone, illuminance with the work zone, UV light effectiveness with the work zone, sound level should always be checked and monitored. Workspace. As with the work on open benchtops, works performed with BSC must be performed carefully and safely. To avoid the contamination and the risk of personal exposure, the CDC advises investigators to follow the best practices to reduce and control the splatter and aerosol generation, such as keeping clean materials at least 12 inches from the aerosol generating activity and arranging the workflow from the clean to contaminated. In particular, open flames not necessary with the clean environment of a Class 2 or Class 3 biological safety cabinets cause disruption of the airflow inside. Once work inside a BSC has been completed, it is necessary to decontaminate the surface of the BSC with other lab equipment and materials. When the BSC is serviced or relocated, including replacement of HEPA filters, it must be gas decontaminated. The gas decontamination involves filling the BSC with a poisonous gas, most commonly formaldehyde gas. So these are all about biological safety cabinets. Thank you.